Hello, and welcome to Lesson 10 of this Introduction to Calculus with Wolfram U. The topic for this lesson is derivatives of trigonometric functions. So, let's begin with a brief overview of the lesson. So, recall that the trigonometric functions are oscillatory, so they go up and down like waves. So, you would expect that their derivatives would be oscillatory too. So here's an example that illustrates that. Here's a function f, which is composed of sine and cosine. And if you plot the function along with its derivative, then what you see is that they are both oscillatory. So the blue graph is f, and the orange graph is f prime. And as f changes in an oscillatory way, so does f prime. But of course, I haven't told you how to find the derivative of f, and that's the goal of today's lesson. The goal of this lesson is to develop a table of derivatives for trigonometric functions. So let's begin with the sine function. So here's the sine function. And to find derivative, we simply apply a definition, namely it's the limit of the difference quotient as h approaches 0, and you get back cosine x. So that says that the derivative of sine is cosine. Let's confirm that with d, and here's a plot of both the functions, sine and cosine. Sine is the function, and cosine is the derivative of the function. Let's go on now to the cosine function. Once again, we apply definition, and what you get back this time is the negative of the sine. So that's important. The derivative of cosine is the negative of the sine function. Let's confirm that with d. You get back negative sine x. And here is a plot of both the function cosine x and its derivative negative sine x. Let's go on further to the tangent function. So here's f equal to tangent of x. Work out the derivative with the definition, and you get back secant square x. So that's to be remembered that the derivative of tangent of x is secant square of x. Let's confirm that with d. And the question is, why is there a square in the answer? Well, when you plot f and the derivative, you see that the tangent function is always increasing. So the derivative as the slope of the tangent is always non-negative, and that's why the derivative has got a square in it. So secant square lies above the x-axis. Okay, now we go on to the reciprocals. So the secant function has derivative secant x times tangent x, and here's a confirmation with d. Let's plot them both, and there you are. Next, we go on to the cosecant function. That's the reciprocal of sine, and its derivative is negative of cotangent times cosecant. Confirm that with d, and once again we can plot it to get the function and its derivative. Finally, we go on to the cotangent function. Now its derivative turns out to be negative cosecant square x. You can confirm that with d. And the question is, why is there a negative sign? Well, the point is that unlike the tangent, the cotangent is always decreasing, and so its derivative is always negative. Okay, so let's summarize a bit. So here you have the 6 functions that we just spoke about: sine, cosine, tangent, secant, cosecant, cotangent. And here are their derivatives. So that says that the derivative of sine is cosine, etc. And that small table is well worth memorizing for all your future work. Let's plot them. And you see that you have all the functions and their derivatives in just one picture, with the top 3 being sine, cosine, tangent, and the bottom being secant, cosecant, and cotangent. Okay, so just a little bit about the higher derivatives of the trigonometric functions. So we know that the trigonometric functions have a cyclical nature. So you would expect that there's some kind of interesting pattern in their derivatives, and indeed that's what happens. So here is a table of the first 4 derivatives of sine. So you got sine x, its derivative is cosine x, its derivative is negative sine x, then negative cosine x, and then sine x. So you see that you're back to sine x after a cycle of 4 derivatives. And that says that, for example, if I ask you what is the 1001th derivative of the sine function, you would say, oh yes, if you divide by 4, you just get 1 as a remainder, and so the answer is cosine of x. And in fact, there's a very nice formula for the nth derivative of the sine function. It's just sine of x plus n times pi over 2. And you can check that that gives you the correct answers when you plug in the values of n as 1, 2, 3, 4, etc. So finally, here is a plot of all the derivatives of sine x, and you see quite clearly that you start off with sine, then you go to cosine, then you go to negative sine, then you go to negative cosine, then you come back to sine. And that is the end of today's lesson, but let's summarize. So because the trig functions are periodic, then so are their derivatives. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant square. The derivative of secant is secant times tangent. The derivative of cosecant is negative cosecant times cotangent. The derivative of cotangent is negative cosecant squared. And that short list should be enough for most applications. Now, this is a very short lesson, but it's a very useful lesson, and it's a very important lesson because the trig functions appear in all kinds of applications, starting from the motions of particles around circles to the electric currents that flow through wires, etc. So knowing the derivatives for these functions is a great step in your knowledge of calculus. So in the next lesson, we'll talk about the so-called chain rule, which deals with compositions of functions. But before then, do revise this lesson and make sure you understand the trig function derivatives. So I'll stop over here. Thank you very much. I hope you enjoyed the lesson.